This is Friedrich Röhle, the godfather of organic chemistry. Hi Friedrich. In 1828, he did something that changed the route of chemistry forever. Actually, it's more precise to say that what he made started the current chemistry science. What have you done, Friedrich? We'll get to that soon, but first we need to understand what was chemistry before Friedrich had done the thing that's unknown for now. Before the 1800s, there was no chemistry. It was even called alchemy. Google says it's the medieval chemical science, but a more accurate description for me would be the capitalist form of chemistry. As people's main concern at that time was to use science to turn metals to gold. That's because it was believed that everything was made out of 4 elements: water, fire, air, and earth. So basically, if you just change the proportion of these 4 elements in anything, like iron or lead, you'll get gold. God, I bet everyone wanted to be an alchemist back then. You can literally imagine the conversation between every single parent and their children. Son, I want you to be a great alchemist when you grow up. But Dad, I wanted to be an artist. You're adopted. Also, a common belief at that time was vitalism, which means that any living thing has a life force that could not be replicated in a lab. Organic compounds were thought to only come from life and could not be made synthetically, and that the only compounds available for us in nature without extraction from a living thing are inorganic compounds from minerals, rocks, and so on. So this really tells you how simple was our understanding for chemistry back then, and how our useful usage of it was so limited, because organic chemistry is the science of designing drugs that treat diseases like antibiotics, painkillers, antidepressants. It's essential in cosmetics and personal care products like shampoos and perfumes. This man spent his whole life interacting with people without even using a deodorant once in his life. Yeah, marketers are dangerous. One common thing between them and bad kids' parents is that both of them are obsessed with turning worthless stuff into gold, except that marketers actually do. So with all those mythical beliefs about chemistry, we can say it was even a science back then. There was no knowledge of atoms, bonds, or molecules. People couldn't explain why certain substances reacted the way they did, and they generally thought that gold could be unlocked from impure metals through spiritual purification or elemental rebalancing. This already sounds like a spell. Eventually, people like Robert Boyle started testing things more logically. In his book, The Skeptical Chemist, he said, "We should stop thinking of materials in terms of fire, air, water, and earth, and start thinking in terms of actual particles and substances." Poor Robert. I think people aren't that open-minded when it comes to gold. And now we're back to Friedrich in 1828. The German chemist was trying to prepare ammonium cyanate, an inorganic salt, by reacting silver cyanate with ammonium chloride. The reaction went like this, producing ammonium cyanate. Just hang on a second, I'm messing with you. That was the expected formula for the reaction, and it's actually what happened first, before the products changed to a substance with completely different properties. When analyzed, the expected ammonium cyanate turned out to be urea. Yeah, urea, the well-known compound found in the urine of mammals. How is that even possible? By rearrangement. Ammonium cyanate and urea have the same molecular formula, which is a thing known as isomerism. Ammonium cyanate decided that it feels like an organic compound trapped in the body of an inorganic compound, so it became urea. And that was one of the greatest discoveries that made the backbone of modern science. Friedrich Röhle was so surprised that he called his mentor Jan Jacob Berzelius, telling him, "Digga, ich bin Magie." This discovery was the first nail in the coffin of vitalism. This was the start to the shift towards the idea that life's chemistry could be understood and recreated in a lab. So 1828 is basically the year organic chemistry was born. And we're about to show you a brief documentary of its life. In 1832, Friedrich Röhle and Justus von Liebig studied benzaldehyde and benzoic acid, introducing the idea of a radical. This term might be familiar to some of you as this, an atom or a group of atoms with an unpaired electron, extremely reactive and short-lived. But what Röhle and Liebig meant by radical is a group of atoms that stick together as a single unit during chemical reactions, moving from one compound to another without breaking apart. Benzoic acid and benzaldehyde, 2 different compounds that both contain the same core part. This group, a benzene ring plus a carbonyl, behave like a single chunk in reactions. They called it benzoyl and treat it as if it was a superatom that could be swapped around without changing its internal structure. Why it was important? At that time, chemists didn't fully understand molecular structure. It was kind of vague for them. The idea of radicals helped them to see that molecules could be broken into stable subunits. It was an early stepping stone towards functional groups, which is the modern concept where parts of a molecule give the molecule its characteristic reactivity. From 1834 to 1839, Jean-Baptiste Dumas and others refined the concept of substitution in organic molecules. Before Dumas, many chemists thought that if you replace one atom in an organic molecule with a different atom, you'd destroy the whole molecule's identity. Organic compounds were seen as fragile, life-made structures that could not survive big changes. The vitalism theory wasn't all gone from people's minds. But while studying chlorination of organic molecules, Dumas noticed a surprising thing. You could replace hydrogen atoms in an organic molecule with chlorine atoms, and the molecule would still behave like the same type of compound. For example, ethanol, replace the hydrogen in it with chlorine. You have chloroethanol, still an alcohol and still reacts like one. He called it the substitution principle. In organic molecules, certain atoms, often hydrogen, can be replaced by others like chlorine, bromine without changing the fundamental structure and behavior of the molecule. It showed that organic molecules can undergo chemical changes while keeping their core identity. It was another crack in vitalism. Another addition to the important landmarks is in 1848 Hermann Kolbe made acetic acid from inorganic sources as well as Friedrich Wöhler did, further eroding vitalism. In 1852, Edward Franklin proposes valency theory. In very simple words, it means that each atom has a fixed combining capacity, a number of hands they use to bond with other atoms. This number is called valency, and different elements have different fixed valencies. Examples: hydrogen has 1 hand, oxygen has 2, nitrogen has 3, carbon 4, and so on. This was huge because it explained why water is always H2O. Oxygen has 2 hands, each holding 1 hydrogen. It gave structure to organic chemistry. Carbon's 4 hands, which means that it could form chains and rings. In 1858, August Kekule proposed that carbon atoms can bond to each other, forming chains. Kekule was really something else. This man discovered 2 of the most basic concepts in organic chemistry by overthinking his dreams. While riding a horse in London, he recalled daydreaming about carbon atoms linking hand to hand in chains, sometimes branching, sometimes in straight lines. Yeah, that's a very common thing that every single one of us thinks and dreams about, along with the Roman Empire. He's also the one who figured out the legendary structure of the benzene ring. In his dream, he saw a snake grabbing his own tail. This image made him realize that the carbon chains could close into a ring, leading to his 1865 benzene ring structure proposal. Wow. Oh my god, a snake grabbing his own tail. This man, Kekule, is a genius. Well, actually, that symbol isn't his. That symbol is the Ouroboros. It dates back thousands of years, first seen in ancient Egypt in funerary texts, adopted by the Greeks from Egyptian iconography, later used in alchemy, Gnosticism, which is an ancient religious philosophical movement that emerged in the first few centuries, mainly around the Mediterranean, and mysticism, which is a spiritual or religious approach that focuses on direct and personal experience of the divine or ultimate reality. That snake symbol is a witch's symbol, to conclude. So he didn't imagine something that was completely new. But I'll give him credit for linking that to the structure of benzene and eventually proving that his link is actually legit. Everything happened before the late 1800s made a very solid foundation for organic chemistry, which led to an exponential growth in chemical discoveries and inventions. From 1869 till the 1880s, development of synthetic dyes from coal tar began, which is considered the birth of chemical industry. In the 1890s, stereochemistry emerged. Stereochemistry is the study of how atoms are arranged in a 3D space within a molecule, and how that arrangement affects its properties and reactions. Even if 2 molecules have the same atoms in the same order, same molecular formula and connectivity, they can behave very differently if their 3D arrangements are different. This is because biological systems, chemical reactions, and even our senses often respond to shape, not just composition. From the 1920s to the 1930s, organic reaction mechanisms start to be understood at the electron level. In the 1940s, antibiotics were invented, and in 1953, the world was introduced to Watson and Crick model DNA, linking organic chemistry to life's blueprint. And from the late 1900s till now, we had new synthetic strategies, organometallic catalysts that revolutionized selectivity, both combinatorial chemistry and high-throughput screening that accelerate drug discovery, green chemistry principles, machine learning, and AI designing molecules and predicting reactions. You know now how organic chemistry has risen as a distinct field, and you know the discoveries that laid the foundation for much of modern chemical science. At the end of this video, I have a message for you, Germany. It's very clear to everyone that my Deutsche Sprache is super cool. I think that makes me eligible for a citizenship. Come on. My Lieblingsbuch is Mein Kampf. Yeah, enough. That's it for today, and thank you for watching, and see ya.